Hi, I'm Mr. Fukuda, and welcome to Honors Chemistry of the Earth. As everyone is well aware, this is far from an ideal way to teach science, but we're doing the best that we can to give our students a solid foundation and prepare them for the time when we can actually return to normal school. So here's some information about the class. So this is Honors Chemistry of the Earth. Some things about the course. What are we studying? Students will investigate matter and properties and the principles that govern its interactions. And they'll also examine the connections between matter and energy in and out of chemical systems, extending the concepts of the movement of energy through the Earth systems and ways human may control these movements. So this is where the of the Earth part comes in. So since this is an honors levels course, materials covered more in depth, faster, and with more rigor. And the course will require content knowledge, but the emphasis is on the application and the problem solving of concepts and principles. Not simply can you just regurgitate what I just told you, but can you apply the concepts and things that they've learned. And this is kind of what makes it hard for the kids. Expectations, simple. They should be completing their work on time. Academic honesty. They know what's right. They know what's not right. And if they're not sure if they can do something, they should just simply ask. Other things, show work when their calculations are involved. Learn and work efficiently. Okay, be prepared. They should be able to take notes while I'm going over some topics. And just because they spend a lot of time on something doesn't mean that they did it correctly. And for most cases, it should not take them a lot of time to do something if they have been prepared before they started doing their work. And respect others. In terms of help, ask for help from me. During class, I'm always online, so if they go offline to work on an assignment, they can still come back during the class time. Or we have academic support from 1:45 to 3 o'clock. They can sign up by appointment. And they can always email me, either through, if they're working on a document, if they put a private comment into it, it shows up in my email, or they can email me directly. So my educational philosophy. Most of you have seen this proverb before. Give a man a fish and you fed him for the day. Teach a man to fish and you fed him for a lifetime. So my philosophy is learn how to fish. I will teach them the materials and skills they need, in other words, guidance that they need to do, and show them how to catch the fish, do some examples, but I won't catch the fish for them. I won't solve the problem for them. I'll give them hints on how to do it, but it's up to them to actually solve them and apply the concepts that they need to do. What are we covering during the year? First semester, we're covering 2 units. These will be broken up into smaller sections, obviously, but Unit 1 that we're working on, combustion, heat, and energy, and we'll be done with those within the next couple of weeks. And Unit 2 will start covering atoms, elements, and molecules. This is kind of the chemistry stuff that we get into. Second semester, we're looking at how chemical reactions work, the dynamics of chemical reactions, and ocean acidification, how it starts applying to our Earth environment. And if we have some time, we'll start getting into the chemistry of climate change. So my grading policy, the grading scale, A's go down to 90%. B's get a lot more lenient, down to 75%, C's 65%, D's 55%. And it reflects our philosophy of what an A student should be. An A student should have an excellent understanding of the concepts, the ideas, how to apply them, how to use them, with about a 90% for proficiency. B students should have a good academic proficiency, and we value that at 75%. About some of the assignments. Labs, we treat them like quizzes because they are testing to see if the students can apply the concepts and gather data, and from using that data, solve problems. So as a result, they cannot redo them after we go over them, because that would be just like letting them take a test after I gave them the answers. They will not be accepted if they are turned in after I've gone over them. Late assignments will be accepted if I haven't graded them yet and gone over them, but if I have, it's the same basic principle. They'll be accepted, but at a lower point value, 20 to 40%. The attendance policy, students have to check in via Zoom each day that their class meets. They should be on time. On most days, I just give them a quick overview of the day's lessons, show them what needs to be done. Then they can stay online if they want to. Most of them will go offline to complete the assignment, but they can always come back if they have questions online and I can help them out, or they can also email me. On days where there would be lectures or discussions, then they're expected to be present until they're dismissed. Here's a quick introductory lesson. Watch the video, then propose a possible explanation for what you just saw.
Okay, so check out those two blocks. Did they look the same?
They do. So I noticed that they're about the same size. They're both black. One is labeled A, one is labeled B. Let me lift them. Oh, this one feels a little bit heavier than this one does. Let me feel their temperature. Put my hand on it. Oh, this one feels colder than this one does.
Okay, so let me take the air temperature first. Okay, and now let's take the temperature of block A. Okay, and let's take the temperature of block B. If I were to put a block of ice on each one, which one do you think would melt faster?
I think B, because B felt warmer than A did.
Okay, so let's try it. Let's put these little rings on there to catch any water.
I'll put them on at the same time. Oh, wow. This one is melting faster. That one, I don't even think it's melting at all.
Which one do you say felt colder?
I said this one felt colder, so I thought this one was warmer, so it should melt the ice faster. But that one is not even anything on there. It's not even moving at all, but this one is almost all gone. Is it maybe because they're different material? They're made up of different materials, I wonder?
Probably. One was heavier than the other one.
Yeah. But wait a minute. When it felt colder, but then you took their temperature was pretty close, right?
Yeah. Well, let's try and take the temperatures now.
Okay.
So that's for A. That's for B. And that's room temperature.
You just saw that video. What do you think happened and why?